Hello and welcome to my YouTube channel ChemWis. In this video, we are going to discuss IUPAC nomenclature of esters. An ester molecule can be represented as RCOO R'. Before going through examples, I will take you through certain points which you should keep in mind while naming esters. Depending upon the structure and number of ester groups, there are two types of nomenclature: OH nomenclature and carboxylate nomenclature. Let's first focus on OH nomenclature. This nomenclature is used for mono and diesters in which ester group is not attached to a ring. While naming esters, R' is named first, followed by the name of acid with ic acid replaced by ate. If R and R' are alkyl groups, then it is named as alkyl alkanoate. If R is alkenyl and R' alkyl, then alkyl X enoate, where X is the position of first carbon of double bond. If R is alkynyl and R' alkyl, then it is named as X inoate, where X is the position of first carbon of triple bond. If there are two ester groups, then depending upon the nature of R group, they are named as dialkyl alkane dioate, dialkyl alkene dioate, and dialkyl alkyne dioate. One thing which I would like to highlight here is that in the case of diesters, parent chain name includes alphabet E. Please note that in OH nomenclature, parent chain includes carbonyl carbon and numbering starts from the carbonyl carbon. Coming to the carboxylate nomenclature, this is used for mono and diesters in which ester group is attached to a ring, and also for any tri or polyester. Depending upon the nature of ring and number of ester groups, they are named as alkyl cycloalkane carboxylate, alkyl cycloalkene carboxylate, alkyl arene carboxylate, cycloalkane XY dicarboxylate, cycloalkene XY dicarboxylate, arene XY dicarboxylate, alkane XYZ tricarboxylate, where X, Y and Z are the position of carbons to which ester groups are attached. One thing which is to be noted here is that in carboxylate nomenclature, parent chain doesn't include carbonyl carbon. Now we will go through examples. We will start with the simplest ester called methyl formate. Here R' is methyl. The carboxylate part has only one carbon atom, so it will be called as methanoate. Thus the IUPAC name will be methyl methanoate. Ethyl ester of propionic acid. Here R' is ethyl. The carboxylate part has 3 carbon atoms, so it will be called propanoate. Thus the IUPAC name will be ethyl propanoate. Another example, here also R' is ethyl. The carboxylate part has branched chain, so we will have to do numbering. The numbering will start from the carbonyl carbon, and it will be 1, 2, 3 and 4 like this. We can see that there is a methyl group at C2. So the carboxylate part will be named as 2-methyl butanoate. Thus, the IUPAC name of this molecule will be ethyl 2-methyl butanoate. In this example, R prime is phenyl, carboxylate part is propanoate. So the IUPAC name will be phenyl propanoate. In this example, R prime is methyl. There are both the ester and keto group in carboxylate part. Ester group has priority over keto. So keto group will be have as a substituent called oxo. This is the parent chain containing 6 carbon atoms. Numbering will be 1, 2, 3, 4, 5 and 6. Here we can see that there is an ethyl group at C3 and an oxo group at C5. Thus, the IUPAC name will be methyl 3-ethyl 5-oxo hexanoate, molecule with ester and aldehyde. Here, the R prime is ethyl. In carboxylate part, the parent chain has 5 carbon atoms. Numbering will be 1, 2, 3, 4 and 5. There is a methyl group at C3. Since aldehyde is also the part of parent chain, so only oxygen will be treated as a substituent called oxo. So the IUPAC name will be ethyl 3-methyl 5-oxo pentanoate. Let's have one more similar example. Here R prime is methyl. This longest carbon chain with 7 carbon atoms is the parent chain. Numbering will be 1, 2, 3, 4, 5, 6 and 7 like this. There is a methyl group at C3. In this molecule, aldehyde group is not the part of parent chain. So the whole CHO will be treated as a substituent called formyl. Thus, the IUPAC name will be methyl 4-formyl 3-methyl heptanoate. Now we will discuss few examples where R group is alkenyl or alkynyl. In this example, R prime is ethyl. This is the parent chain with 5 carbon atoms. Numbering will be 1, 2, 3, 4 and 5. Here we can see that the position of first carbon of alkene is 4. So the IUPAC name will be ethyl pent 4-enoate. In this example, R prime is methyl. This longest chain with 7 carbon atoms is the parent chain. Numbering will be 1, 2, 3, 4, 5, 6 and 7. Here we need to mention the configuration of alkene, which is Z. I am not going to discuss about how to find the configuration of alkene as it is beyond the scope of this lecture. I have made a separate video on this topic. The link for the same is given in the description box of this video. There are 2 substituents, a chloro at C4 and a methyl at C5. Thus, the IUPAC name of this molecule will be Z methyl 4-chloro 5-methyl hep 4-enoate. This is an example where R group has an alkynyl group. R prime is ethyl. This is the parent chain with 6 carbon atoms. Numbering will be 1, 2, 3, 4, 5 and 6. Here the position of first carbon of triple bond is 4. So the IUPAC name will be ethyl hex 4 inoate. Let's have few examples of diesters. The first is diethyl glutarate. Here the two R prime groups are ethyl. Parent chain has 5 carbon atoms. So the IUPAC name will be diethyl pentane dioate. Diethyl tartarate. Here also the two R prime groups are ethyl. Parent chain has 4 carbon atoms, which is numbered as 1, 2, 3 and 4. Here we can see that there are two hydroxyl groups at C2 and C3. So the IUPAC name will be diethyl 2,3 dihydroxybutane dioate. Examples of diesters with double or triple bond. Dimethyl malate. Here the two R prime groups are methyl. It has 4 carbon atoms in the parent chain with a double bond having Z configuration. So it will be named as Z dimethyl butene dioate. Dimethyl fumarate. It is the geometrical isomer of dimethyl malate having E configuration. So it will be named as E dimethyl butene dioate. In this example, the two R prime groups are ethyl. Parent chain has 6 carbon atoms with a double bond at C2 having E configuration. So it will be named as E diethyl hex 2-ene dioate. Acetylene dicarboxylic acid dimethyl ester. It will be named as dimethyl butyne dioate. Now we will discuss examples where carboxylate nomenclature is applied. The first example is the ester in which R group is cyclohexyl. We have already discussed in the beginning that such compounds are named as alkyl cycloalkane carboxylate. Here R prime is methyl. So it will be named as methyl cyclohexane carboxylate. Another example. This is an example where R group is cyclohexene. R prime is ethyl. Numbering a parent ring will be 1, 2, 3, 4, 5 and 6 like this. As we can see that the position of first carbon of alkene is 3. So the IUPAC name will be ethyl cyclohex 3-ene carboxylate. Benzoic acid methyl ester. As we know that when R group is aromatic, then the IUPAC name is alkyl arene carboxylate. So benzoic acid methyl ester will be named as methyl benzene carboxylate. 6-methyl nicotinic acid ethyl ester. Here the aromatic ring is pyridine. In a heterocyclic system, numbering starts from the heteroatom and follows the direction giving lower number to the carbon bearing ester. So numbering will be 1, 2, 3, 4, 5 and 6 like this. Here we can see that R prime is ethyl. Position of ester is 3 and that of methyl is 6. So the IUPAC name will be ethyl 6-methyl pyridine 3 carboxylate. Citric acid trimethyl ester. In this there are 3 ester groups. So parent chain will not include carboxylic carbon. So This 3 carbon chain will be the parent chain. Numbering will be 1, 2 and 3 like this. The parent chain is propane with a hydroxy group at C2 and 3 esters, 1 at each carbon atom. R primes are methyl, thus the IUPAC name will be trimethyl 2-hydroxypropane 1,2,3 tricarboxylate. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.